workspace, finance and corporate governance, academic track, you will see the link to the study material. And in the course contents and study material, there is a folder of spreadsheets. And in the spreadsheets, I have just now, a minute ago, sent you the data called research methods data. So please open this file as well. So if you go to your Moodle, and you can get the research methods data, because this is the data which we shall practice with in SPSS. Okay. Do we have this kind of workspace? Yeah. Do we have it? So this is your SPSS workspace. And then if you open up your research methods data file in Moodle, keep it open. I strongly advise you that don't stay behind. If you miss any step, just raise your hand so that I keep you along with me. You need to, yeah, get the recording. So this is the spreadsheet that we see, and this spreadsheet is available in Moodle. And here you can see that this is a normal spreadsheet, the name of the variable. Free cash flow, don't worry about what it is, because I'm just using this dummy spreadsheet to explain the mechanism of SPSS functioning. So we have revenue of companies, and here you can see that the number of rows, this is some past data of one of my students who did this research. So we have about 100 firms data. So you can see that about 150 data sets, the rows we have. And here we have the variables. Always remember that whenever you are doing your data management, you need to make sure that always save the variables in the form of columns like this. So if you have free cash flow here, total revenue here, this operating profits here, and the things are column wise, it will be not good. Sorry, row wise, it will not work. Always make sure that the name of the variable is in the column A, column B, column C, never row wise. Okay. This is the normal layout. What I do, I have the spreadsheet. So I also suggest you, all of you, that when you start working on your thesis, make sure that the data is first saved in a normal spreadsheet. And from there, you can copy and paste, or you can export to SPSS. Okay. So always have your principal, the primary data should always be, not primary, secondary, that means, but the original data should be available in some old-fashioned spreadsheet. Okay. So Excel spreadsheet is very, very useful, even though we use the softwares. Okay. So what I'm going to do is I'm going to copy some of these columns, copy them, and then take them to SPSS workspace, and first column, first row, and I click right. It might be a bit slow. And it says paste or paste with the variable names. I would always click paste with the variable names, because then I don't have to type it. You get my point? So always paste with variable names, because remember that in the spreadsheet, I copied the whole column, including the name of the variable. And when I go to the SPSS workspace, I need to paste with the variable names. It's a little bit slow, but it works. So look now, these names which I had, the data is now available in SPSS workspace. You can change the width of the column if you want, no problem. Are here. We all are here now. Yeah, all good. And then I go to the original spreadsheet once again, and there is a variable called which you need to pick up is this red one, the first red one, which is the annual firm stock return. So I copy it once again, annual firm stock return. And again, I go to the SPSS workspace, click right, paste with the variable name, and it shows me the annualized stock return. Remember, in this workshop, I shall be using the annualized firm stock return as my dependent variable and all others as independent variables. Yeah. So I would assume that all other variables have an impact on the company's annualized firm stock return. I have some more variables which I can take in this exercise. And these are, for example, the annualized FTSE return, because this is the index. So I choose from column K. Then LM, price to earning ratio, the median board size, so and so on and so on. What I'm doing basically. Just a sec. I think I done. The annualized FTSE return. So I take it, I copy it, and then I save it here. Paste it here, rather, paste with a variable name. Yeah. And then I take some more variables. Because remember that in the regression, when you do, you have one dependent variable and several independent variables. And then I take from column M, log of market cap, P to E ratio, the board size, the education of directors, experience of directors, debt to equity ratio, innovativeness. And we save them here. Rather paste them with variables name. And now you can see that we have almost a similar to spreadsheet looking view we have in SPSS workspace. Definitely from here, you can change the width of the column. It's quite just like spreadsheet, the normal spreadsheet. A very important thing you can notice is that in the bottom left corner, it says data view. And then you also have a click variable view. And when you click the variable view, you have this type of scene, this type of layout. And here you can see that the names of the variables are given. So we have altogether 14 variables. In our study, we shall use the annualized firm stock return as a dependent variable and all others as the independent variable. So you can edit the name, like I click one wrong word. So you can edit the name of the variable. The variables are numeric. Numeric means they have the numbers. But one thing I would suggest you that because we have many decimals, so increase the decimals to maybe 4 or 5. So it's a good idea. The idea is that imagine if a number is 0.0067, and in fact all the numbers are starting from third or fourth decimal point, and you have only 2 decimal points, then all of them will become zeros. And if everything becomes 0, there's no analysis. You get my point? Some numbers are very small, and they start from second or third decimal place, and by default, SPSS tells you 2 decimal points. So if the numbers are very small, they're starting from third or fourth decimal point, and you take second decimal point only, then all of them will become 0. And if everything becomes 0, there's no analysis. So my recommendation is that, depending upon like for example, revenue can be in millions. So there's no need to have even 1 decimal. But those numbers where you need to decide, you decide that how many decimal places you should take. I would say that if I were you, I would take at least 4 to 5 decimal points. You can't take more. I think maybe max 5 you can take. So what I do, I change all the numeric variables to 5 decimal places. Even though I don't need to change for the some of them, but I just do it, no problem. It doesn't matter. That will not be it will not cause me any harm, by the way. So 5 decimal places. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. Yeah. 3, 4. Whenever we do, now our variables look okay. Everything is fine. We can call them, yeah, nominal. Yeah, it's fine. It's okay. Everything is fine. There's no problem. So the only thing I would change is that if the need be, I have to change the names of the variables, and I have to make sure that the decimal points are 5. Okay. Are you all here? Excellent. Now, we shall be using 3 types of analysis. Yep.
I can change the decimals on.
Is numeric. Only then you can change decimals. Yeah. So if there is something else just by mistake, by default, change it to numeric. Good point. Now, I want to show you some thesis of a student. Not this one. Thesis.phi. Let's take the thesis by Christina, for example. It doesn't matter. It's a very good thesis, by the way. Christina has done the association between performance-based compensation of CEO and firm performance in the Nordic corporate sector. But just that's not my point. As you can see in the computer screen, when we do the analysis, I can show you from the contents page. Yeah. When we do the analysis, the data analysis, the 3rd chapter, the data analysis on page 34. Oh, wait a sec, on page 34. Well, let me see the contents. Yeah, you can see that there are 3 types of analysis that we do. And the first one is, as Christina mentioned, and you can see here, most of you, with some exceptions, would be having 3 stages of data analysis. The first would be called descriptive statistics. Descriptive statistics basically means what is the data's characteristics. Have you heard about this phrase called teaser or a curtain raiser? Have you heard it? Have you seen a movie's teaser? Not the full movie. Like for example, the movies which will be released next month, they show some teaser for a few seconds. So the data, descriptive statistics, is like a teaser of your analysis. You can't really conclude anything from that, but this basically tells you how the average of your data looks like. How does it show? And if there's some major concern, you can be worried about it. So the descriptive statistic is more like a showcasing. You showcase your data. And as you can see, I can take you to page 41. Descriptive statistics, where is that? Yeah, here we go. Normally, we have the mean value. Mean, you know the mean value? What is mean?
Average.
Average. Do we use mean for some other expression also? This person is very mean, but not that mean, okay? Not that mean. Here, mean means average. Average, and yeah. And standard deviation. Standard deviation shows what? What does standard deviation show? Risk. Good point. And we have done it in which course? Financial management. But in general, standard deviation means that how fluctuating, how wavery the data is. You're right. Because if the data is moving too much, there'll be more uncertainty about the pattern of the data. Predictability will be low. So the standard deviation is measuring how much fluctuating the data is. Look at this. One of your variable is moving at 0.118. And this, look at this one variable. This is moving at 1,261. And this one variable, which is even having the standard deviation, 11,238. Goodness gracious me. So all the variables, they have a different degree of fluctuation, okay? Maximum, you know, the highest value in the whole column is this much. For example, highest profit has been 7879, and the minimum profit has been -3789, which means loss basically. And the range is the difference between maximum and minimum, okay? So these are, we can't really conclude anything from this descriptive analysis, but descriptive analysis helps you to get some feel of the data. All right. So this is what exactly I would do. So now you know that the first phase of your data analysis is descriptive statistics. Okay, all good. Now we go back to our lovely SPSS. And now we go back to the data view. Yeah, you see the variable view? Go to the data view. And once you are in the data view, there are so many bars here. They're very confusing. And here, click Analyze. Analyze is the link that we shall be using super frequently. Analyze. Sophia, you see it? So this is Analyze. And here you see the descriptive. Can you see it? Analyze, descriptive, and descriptive again. Since it's been recorded, you can see it, but this is quite simple. I mean, if I'm not recording it, I would take you to take the screenshot, but there's no need for this because we are recording it. Okay. So I repeat, analyze, and remember what we were going to do, what we saw in that thesis, descriptive statistics. And what descriptive means, they just describe how the data looks like. It's like meeting somebody first time. You don't know the person yet, but it's like the first handshake, the first time you know the data, okay? And that is called descriptive statistics. We see the mean, the average, then we take the fluctuation, the standard deviation, the highest value, maximum, the lowest value, the minimum, and the difference between the two called range. All right, so now we go to analyze descriptive statistics and descriptive. And here you can see that we have this kind of dialog box. Do you see it? Do you see it? I would say you can put the variables one by one. Can you see it? I always call it like it reminds me of football pitch, the football match. This is your football pitch. the ground where you play football. And this is a dugout. You know what is called dugout? Where the players are sitting. So if you want to bring a player, select it. Oh, and bring it here. Look, the player comes. And if you want to send the player back, send it back. If you want to pick them one by one, it's okay. But if you want to pick, for example, all of them, then you can use the shift function and you can select all of them. And you can bring them here in the one go. Should I repeat it? Should I? Look here, options. What do you have in the options? You have the mean, you have the standard deviation, you have the maximum, you have the minimum. And if you want, you can have the range as well. It's like shopping. It's like a buffet. You can pick up whatever you want. Yeah. So it's like your choice what you want. So we have the mean. By some things are by default, but the others you can pick and choose. Standard deviation. These are something very normal, mean, standard deviation, maximum, minimum, and the range basically. So continue. I will not click anything else, and then I would click OK. Here we go. And now you can see each variable has 149 observations. Remember the spreadsheet? We had 150 observations. The first row was the name of the variables. So, you can see that this is the mean 54.7983 whatever. Remember, see there are too many decimals, right? But we can shorten them afterwards. No problem. So mean is there. Standard deviation is here. The maximum value is here, the minimum is here, and then the range is there. So everything that we need, we have. And by the way, once you get your results, you can copy as, for example, you can save, because after all, you have to save your results also. I do it again. So if you have this, if you click right, you can copy as the Excel workspace. And if you can even export, by the way, you can even export to some page or whatever. But I normally use this function, copy as Excel worksheet. And then I open a new spreadsheet, for example. For instance, maybe this is something else. Maybe I open a new spreadsheet and Excel. And here, if I paste, yeah. So now my results are saved, by the way. So after I have done my analysis, I can save my results. Of course, I can save. All right. In today's exercise, I don't really want to explain too much what is mean, what is standard deviation, but I told you the basic meaning of them. But this is not a statistical workshop, it's SPSS workshop, okay? So I assume that you know the basic terminology meaning, but of course I would explain it to you if the need be, okay? So now we have saved our findings, okay? And now you can see that this table looks like what this resembles like Christina Borain's thesis, yeah? Here we go. How much time did we take, by the way? A few seconds. Analyze descriptive statistics, and then we did the shopping. this, click OK, here we go. And then copy the column and save it. So simple. Okay, then the second analysis that we perform is called correlation results. Correlation means what is the degree and direction of two variables being correlated. And very quickly, I can share with you that correlation basically means that whether two variables are correlated, they have a same association or not. Okay, so for example, if I take advertisement expenditures and sales here, two variables, it could be that all of them are lying on the same straight line and the line is going upwards. So we can say that the variables are positively correlated. And similarly, I can have another example when I say that the number of policemen in the city and the crime ratio. What do you assume? What do we assume the relationship between the crime rate and the number of cops in the city? Negative. And how do you know that it's negative? It comes from literature review. You must have read the literature. This is why before you reach this stage, you need to do what? Chapter number 2. And what is chapter 2? Literature review. And what does it tell? It tells all the theoretical arguments. In the theoretical arguments, we know that in theory, there is a negative relationship between the policemen in the city and the crime rate. We assume that more cops in the city will be more peaceful, the crime rate will go down. But you don't know until you analyze your own data. If you find the same result or opposite, it could be possible that in your case, the cops are hand in glove with the criminals, and in your case, the result is opposite. You never know. Or the third possibility is that you are not able to establish if such relationship exists or doesn't exist. Look, the three things. One is you prove something. The second thing is you disprove something. And the third thing is you're unable to prove or disprove. Life is black. Life is white. And what else? Gray, the gray areas. So this is possible. So we assume in this case that the curve is negative. More, if all the variables are falling on the same line, then we say the perfect positive correlation or the perfect negative correlation. But sometimes we feel that in the real life, the correlation is not perfect, but there is some spread around. More spread means more standard deviation, basically. Okay, so the correlation, you know the correlation now? The correlation shows the degree and direction. The degree can be very high. The correlation highest can be +1. And the correlation least can be -1. -1 means perfect negative. It means you increase the cops by 10% in the city, the crime rate will exactly go down by 10%. Then it's -1. And here, you increase the advertisement expenditure by 10%, the sales would increase by exactly 10%. So the correlation is either perfect or less than perfect, okay? So anyways, your correlation is always between, your correlation highest is +1 and your correlation least is -1. And if there is a zero correlation, which means no correlation. So zero is in between, of course, -1 to +1. So as a benchmark, remember, if you are doing the calculation by yourself and your correlation is 1.23, you don't have to check, it's wrong. Because highest correlation is +1 and the least correlation is -1. Correlation can never be more than 1 on either side. because it's a standardized measure. It's a standardized measure. Yeah, so I take you back to the regression. Sorry, to the SPSS. To analyze, I go by Christina's thesis. So that the second stage is called analyze once again. Oh, analyze. Look at here. Analyze, correlate. You see it? And when we say correlate, bivariate. Why bivariate means? You know the meaning of bi? Have you heard about bicycle? Two. Because at the moment, we can have multiple variables, but at a given point of time, in a given situation, we can only analyze two variables. Okay, so I repeat, analyze, correlate, and bivariate. Are we all at the same page, same level? Excellent. And once again, we have a dugout and we have the variables, right? So what we do, we can, with the shift thing, we can select them, all of them, and then keep it here. By default, the correlation is clicked as Pearson. Pearson is Carl Pearson, who have given the most famous formula of correlation. And we stick with this, yeah? We stick with this. And nothing else we change. Two-tailed, one-tailed, two-tail is fine. I'll explain the meaning of two-tail a bit later, or one-tailed a bit later. But options, do we have something in the options? No, continue. No, nothing else. And style, no need to change any style. And then click OK. And here you can find the correlation matrix. You can see the correlation matrix. For example, the variables are row-wise. The variables are column-wise, yeah. The correlation between free cash flow and free cash flow will be 1, you know, itself. But look at this, correlation between free cash flow and total revenue is minus 0.95. So basically it means that whenever the correlation, whenever the total revenue goes up, the free cash flow goes down. Does it make sense? Yes or no? Yes or no? So you can see that each variable's having a correlation with the other. And then the total revenue with total revenue, operating profit with operating profit. So this, they will always be 1, 1, 1 because they are correlating with itself, basically. A very important thing, which you need to know, even though it's more about statistics thing, about the theory of statistics, but I think it's a good idea to discuss with you. We use a phrase called level of significance. Can you see here? Level of significance. Don't worry about two-tailed, but sig means significance. The question is that our correlation between free cash flow and total revenue is minus 0.95, but the level of significance is 0.247, which basically means 24.7%. In statistics, in econometrics, in quantitative methods, we use the highest level of significance we use is 10%. 10%. Okay. And to understand the level of significance, the idea behind level of significance, I have to tell you a story. The story is that, or I have to narrate a situation. And the situation is that, imagine you all are my investigators, spies, cops, and I am your chief police officer. and you are investigating some crimes in the city committed. So you are undercover spy, you are making some investigation. And imagine Senior comes to me and she said, Shab, this is my report. Remember, I was probing, I was investigating this bank robbery, and this is my report. And she's explaining me that this happened and this happened and this guy, we got a lead. This guy seems to be the friend of the cops of these robbers. If we catch him, we can even get the robbers, even though they have went to the other country, but their parents are here, their family is here. We can ask them where have they moved in Spain. It's a good story. Senior, sounds good. And then I ask you, okay, let's have a meeting, because after all, if I have to take some action, if I sign, okay, go and arrest him, it means something. It's a very responsible thing, yeah? Basically, now I'm investigating my inspector, how well she has done the investigation. And I find that she's answering me some questions, but I still I believe that there are some loose ends in the investigation. And then I finally ask her, Stenia, on a scale of 0 to 100, how confident you are that I can trust your investigation before I order the arrest of this person? And she says, Shab, be truthful. I think there is a error. There can be error of 5%. There can be error of 5%. It means that I can say that my report is correct by 95%. Now, here, the 5% is level of significance. And what's the maximum level of significance I accept? 10%. So 10% is the maximum potential fluctuation we can accept, not more than that. If she says that, you know what, I think there can be about 12%, 13% possibility that my report has some loose ends, then I would say, let's not arrest him, do some more investigation. Or it could be possible that she is thinking this person guilty, but he or she is actually innocent. So we don't arrest, we let him go. But if the level of significance is 10% or below, it means I must take some action. It means that if I say 5% error is allowed, it means that my level of confidence is how much? 95%. So it means higher the level of significance you take, lower would be your level of confidence. So we want more level of confidence or lower level of confidence? More. It means your level of significance should be less. So therefore, never take level of significance more than 10%. Look at this. Now see, this is very interesting. Please pay attention here. The correlation between the free cash flow and total revenue is minus 0.95. We all agree? The question is that after we get the numbers, we need to check, is this correlation significant? And look at the significance level. How much is this? 24.7%. Should we accept it or not? Of course not, because it's more than 10%. So the result would show up no matter what you do. The question is that, should we accept this result or not? This result is insignificant. Are you with me? Maximum level of significance you take is 10%. 10% means if I put in fraction like this. Yeah. Have a look at this. Have a look at this one. Natural log of free cash flow and annualized stock return. Look at this. Can you see here? The correlation is 0.299 for me. So the correlation is what? Positive. The correlation is positive. How do I know it's positive? Because the sign is positive. And the correlation between free cash flow and total revenue was negative. And how do I know it? Because sign was negative. Can you see the signs? Plus, minus. Plus we never write, but minus we do write. But look at this one. The correlation is positive. And look at the significance level. How much is this? How much is significance? 0%. And if the level of significance is 0%, how much confident are you? 100%. So we are 100% confident that the correlation between the log of cash flow and the stock return is positive and significant. You with me? So that is very important thing. I don't know how much you are aware or not, but this is a very important addition to your knowledge, that you not only make the calculation. Look, the calculation will show up no matter what, the data in, the output out. But the point is that you need to make a judgment. Is this result significant or is it not? And this, we use the parameter of level of significance, highest to 10%. Yes.
Let's assume that I need to.
It's a number of police officers, number of cops. And this is not total revenue, this is the crime rate. In the theory says that there is a negative relationship between the number of cops and the crime rate. And we also find the negative sign. If you are not a trained quantitative analyst, you would say, bravo. Look, in our case also, the correlation between the crime rate and the number of cops is negative. But you missed very important thing. How confident you are, how much you trust the analysis. And that significance level is 24.7%. Absolutely unacceptable. Even though the results are pointing out that there is a negative correlation between the crime rate and the number of cops, but you don't have enough evidence to accept it. Look, we always say the person is innocent until proved guilty. And this level of significance is showing us this idea, unless proved guilty. It seems that there is a negative correlation, but we can't really trust it. We can't put those people behind the bar or whatever, because we don't have enough evidence. We don't have enough evidence. If the level of significance is more than 10%, you have not enough evidence to take any action. Haven't you seen that sometime in the major crimes, some people are picked up by the cops, but later on they are released? And what is the main criteria of letting them go? The court says that we don't have enough evidence to punish them. Do you get my point? Do we punish somebody without having any evidence that he or she is a criminal? No. The benefit of doubt always goes to the guilty person. In the modern states, whenever there's a doubt, even though you have some evidence, something, but if you don't have a conclusive evidence against that person, you never punish him. And in fact, you give the benefit of doubt to that person who's accused. You can't just hang a person just because you have a doubt on that person. Maybe in some countries it happens, but it shouldn't happen. So therefore, if the level of significance is more than 10, we never accept the result, and we always give the benefit of doubt to the other side that no, we can't accept this result. We can't accept this investigation. Either something is wrong with the investigation, do the re-investigation, change the form of the variables, do some other type of analysis, or just let the person go. Don't accept it. in your data analysis, you don't have to accept every result, by the way. Don't go with this notion. I just published one article and it's going on soon, me and my colleague on Escola. We have 7 independent variables. None of them is significant. None of them is making any impact. When you proving something is a good thing, yeah, is adding to your knowledge. But even disproving something is also adding to your knowledge, because something you think that, okay, maybe this thing impact this thing, but you prove with the data, no, it doesn't work. So just as proving is important, disproving is also equally important. So when you do the data analysis, never go with this kind of pressure that you have to prove the variables less than 10% significance. No, don't go with this notion. If some phenomenon, the relationship is significant, okay, good. If it is not, it's not. What can we do? Okay, so now, as you said that I want to prove that this is this, I want to go with this. No, don't go with this. You have to have an impartial investigation. Even though you are a cop, but your investigation must not be biased. So think like a cop when you are doing your thesis research, like your data, like your topic, but at the same time, when you do the analysis, don't be biased. No, it's a very good point you raised.
I just thought that I just have to.
Or like, for example, look, this is very tragedy. Here we have FTSE return, and what is this thing? 101. We have the free cash flow. Look here. Goodness gracious me, where is the correlation? No, that's a significance level. Okay. So now you know the idea of significance. Okay. So some variables are significant, some are not significant, and no problem. So we say that this correlation, this pair of correlation between variables we accept. This is significant, and this we don't accept. So this is because it's insignificant. So it's very straightforward. And again, the benchmark is 10%. And you can see here, I can show you in this thesis file. Where is it? Yeah, it's here. Correlation analysis. And you can see here, correlation with significant at 1%, 5%, and 10%. Yeah. So the highest significance level is 10%. She didn't put a 0 because it's 0.1 is also 0.10. So that's why. And here you can see that the correlation. Yeah, so there's a matrix. Yeah, can you see it? Because she has many variables. So she, instead of writing the full name, because otherwise it will not be, so she labeled them as x1, x2, x3, so on and so forth, right? So she called the dependent variables as y1, y2, y3, and the independents as x1, x2, x3. Very nice way of saving the space. If you have too many variables, she has how many? Oh my gosh, she had 10 dependent and 11 independent, 21 variables. There's no other way than this. So you label them, but the idea is still same. You see here, the one which are significant are put with a star, and the one who are without significance, they don't have star. So it basically means that the one with the star are significant, the one without stars are insignificant. Right? But I will teach you those things when we reach at that stage. But the idea is that the student has distinguished between the significant results and insignificant results. And the rule of thumb, you can see some are 3 stars, some are 2 stars. Can you see that? Some are 1 star. The rule of thumb is that if something is, if there is a, let's say 1%, let me do it. The rule is that if there is 1% level of significance, it means the level of confidence is 99. We put 3 star. Yeah. And if it is 5%, the level of confidence is 95%, we put 2 star. So anything between 1 and 5, you carry 3 star. And if the level of significance is 10%, which means confidence is, we put 1 star. Okay. So even within the significant, we can say who is the most significant, who is medium significant, and who is less significant, but not insignificant, with the 1 star. Okay. And imagine if it is a 12%, then this would be 88%. This is insignificant. This is insignificant. We don't accept it. The calculation is there by default, but we don't accept it. All good? Yeah, very good. Now, the third and the last analysis, today I would do the regression analysis, right? Regression, which the student has also done. Yeah, here is the regression. Next week when we meet, we shall do more advanced. Even this is quite advanced, but we will do even more advanced analysis. The correlation is that the correlation tells you if these 2 variables are related, like crime rate and the number of cops, the amount of advertisement and the amount of sales revenue, but it doesn't show the cause and effect relationship. So if you have to study, does crime rate is affected by the number of cops? Look, in the theory, both things can come. More crime rate means you need more cops. So the number of cops recruitment depends on the number of crime. You see, the city with more crime have more cops, and the city with less crime have less cops. So you can say that the number of cops, Y, depends on the crime rate. But on the contrary, you can also say that the crime rate also depends upon the number of cops. Can you see the cycle? So which model you take, it depends upon your thesis objectives, number 1, and number 2, how you have gone through the literature, what literature is basically saying. Okay, so you make your own models where you have one Y. Y is always labeled as dependent variable, and those X's, X1, X2, X3, they're called the independent variables. Okay, and I can show you, don't get scared, because this student has many dependent variables. So you can see that she has one model in which the performance pay is a dependent variable, and she has many independent variables. Look, she has taken 14, 15 independent variables. Can you see that? So depending upon, yeah, but that's not my point at the moment. I take you to quickly to the SPSS. Imagine in this dummy example, the annualized firm stock return is your dependent variable, yeah, and all other variables are independent variables. You with me? Have a look at this. So basically, I'm trying to say that the annualized stock return of the company depends upon the index return, depends upon the company's market cap, price to earning ratio, the board size, education, experience, and even innovativeness. Can you see that? It means I'm investigating that are all these variables have an impact on the company's stock market performance. Can we say that the more innovative companies have better stock market performance? Can we say that the more experienced board of directors and more educated board of directors have a better impact? So when you buy the shares of a company, do you see that who are the board of directors? More educated, more experienced, people like Bill Gates, people like, you know, the big names, Elon Musk, or, you know, so what was the name of this guy who died? The CEO of Apple? Not Bill Gates is alive, huh? Steve Jobs. So when you see these kind of people, yeah, and when you see that people like Warren Buffett are the shareholders of this company, you want to buy those shares. So even who are the leadership, the kind of leadership also. So what I'm trying to investigate is that the leadership of a company, the innovativeness of the company, the profitability of the company, do they all have an impact on the company's stock return? You understand it? So you can only have one in a given model, you can have only one dependent variable, but you can have multiple independent variables. So in this dummy exercise, I would assume that the company's stock return, which is number 6 variable, depends upon the index, depends upon the market cap of the company, depending upon the board size, depending upon the education, depending upon the experience, depending upon the company's innovativeness, depending upon company's profitability. So I'm planning that how these different variables have an impact on one variable called company's annualized stock return. All good? Bravo. Let's go to the data view. And once again, we are in the analyze, but this time, can you see regression here? Can you see it? Analyze, regression, and linear regression. Next week, when we meet, we will also do the non-linear regression, something which is not linear, but this is a basic regression. Yeah. Have you seen this equation? I must have made many times that y is equal to alpha plus beta 1x1 plus beta 2x2 likewise. Yeah. You must have seen it. For example, when you do the financial management, you calculate beta, systematic risk, the company stock return, the index stock return. This is beta. This is what? Alpha. Which alpha? Jensen's alpha. You see that? So you know these terms already. This is strange that you know the meaning of these things, the practical meaning of these words, you know it already. But in theory, we can have multiple independent variables. So anyway, so we go to linear. Now, you see, there are two fields, one for dependent and other for independent. Now is there a difference? In correlation, there was no such difference because all of them, we merged together. So please tell me, who is our dependent variable this time? Annualized return of the firm. I select it, I put it here. Okay. And then all of the variables, you can select if you want, you can do the pick and choose, but because I'm just doing some exercise, so I pick all of them in the one go. And I put them in which category? Independent. So this is Y. See the cursor? This is Y, and these are X1, X2, X3, so on, so forth. Yeah. And then statistics. Look, we need to take the estimates, they're by default. This is very important, confidence interval. How much confidence we take, by the way? Sorry? That is level of significance, 90. By default, it here is 95. Look, you can change, make it 90. By default, it's 95, but you can make it 90. Don't worry yet. Today, I will not explain it. But just if you want to take, look, descriptives, can you see descriptives? And you have got them already. So if you want, you can also re-get descriptives even in the regression process as well. Don't worry about anything else. I would redo next week, and I'll explain to you the Durbin-Watson and collinearity next week when we meet. But for today, we only take estimates, confidence interval, descriptive, and that's it. Nothing else. Okay? Sorry? Oh, that's fine. That's okay. No problem. Is anything else we need to take? No need. Maybe, yeah, this is fine. Okay, and click OK. You see, you get the descriptive ones again. Of course, you only get mean and standard deviation. You can, This is the correlation. You know correlation already. But the most important thing is this. The most important thing is that, please pay attention, it's very important. Your Y is annualized firm stock return. And these are the different X, X1, X2, X3. And this is the alpha constant, the intercept term, right? The first thing, look, there's so many information in this table, okay? When you have so much of information in a table, you should not see what you want to see. You first see what you should not see, okay? I will not see this thing. I will not see this thing. Only three things I would see in this entire table. First, this beta, okay? The second thing I would see is T value. And the third thing I would see is called, I would say that I will not even see the T value. Only two things I would see, the beta and the significance level. Beta and significance level. Okay. Please remember, what was your dependent variable? The firm's annualized stock return. Okay, the first X, the first independent variable is free cash flow. Free cash flow, does it affect positively or negatively? Does the free cash flow, let me put the question, does the free cash flow affect the stock return positively or negatively? Positively or negatively? Leong? Positively or negatively? Positively. Do we only take the sign positive or we see the significant? Is it really significant? Look at the level of significance. How much is that? 34.3%. The level of significance is 34.3. Would you accept this result or not? No. It means the free cash flow does not have any impact on the firm's stock return. Even though the beta coefficient exists, but it is insignificant because the level of significance is more than 10%. Have a look at this total revenue. The sign is, what does it mean? It means that those companies whose total revenue is increasing, their firm stock return is going down. So those companies who are doing good accounting performance, their market performance is bad. But are you sure this is acceptable finding? Look at the significance level. 3.6%. 3.6%. Accepted or not accepted? Accepted. Very good. Congratulations. Is it accepted at 1%, 5%, or 10%? Do you accept it 1%, 5%, or 10%? Huh? No. Is it close to 5% or 1%? So when you show this result, you put how many star on top? 2 star. So the result is accepted. So you are able to prove something, and that proof is that higher the company's total revenue, lower is the company's market performance. Don't ask me why, because this is just a random data, okay? Free cash flow. The companies which have more free cash flow, the stock return is positive or negative? Is a positive relationship or negative relationship? The company whose free cash flow is more, the stock return is going up or down? Because the sign is positive. It's like correlation, right? The sign is positive, but is it significant? Yes, 3% significance. It means 97% confidence that this result is acceptable. Okay? Look, you're only looking at 2 columns. beta, and significance. And that's all you need. Victoria, does it make sense? Okay. Operating profits. Operating or profit have a positive impact on the stock return, which means higher the operating profits, more the stock return, lower the operating profit, lower the stock return. But can you say with confidence? No, it's 18.4%. And this is not, so this is the result which we are not able to prove. You remember, the person is innocent until proved guilty. We don't accept this investigation. And this is the least accepted. Look at the significance level. 99.3. So the confidence is maybe 0.07%. So this is unacceptable. Let me focus on, look, this is acceptable. Can you see it? 6%. And the relationship is negative. It means that the companies which are bigger in the market, their stock return is down. So the larger the company is, lower is the stock return. And this you can say with 94% level of confidence. Do you all agree? So this way you are able to prove what? You are able to prove whether X is X1, X2, X3 was whatever, who is significant, who is not significant. To me, these values do not matter at all. To me, what matters is the sign, positive or negative. And then most important thing, if the result is significant or not. Honestly, when I do my research or my students do, I don't even care the value of the sign. So I don't see the quantity quantitatively. I see the quantities qualitatively. Sign is positive or negative, and then most importantly, is it significant or insignificant? So in this analysis, you can see that the total revenue is significant but negative, which means more revenue, less stock return. Log of free cash flow is positive and significant. This is accepted. And then finally, debt to equity ratio. The company which have more debt for equity, their market performance is good, positive, and this you can say about 94% confidence. Innovativeness, this is strange. The companies which are more innovative, they have poor stock market performance because maybe investors don't like them, speculating too much. And this you can say with 96% of confidence. So the idea is that you are able to prove or disprove certain things. Am I right? Do you understand? So you understand correlation, you understand descriptive statistics, and you also understand what? Regression. One last thing before you go. I go to the spreadsheet again. I'm in this SPSS data sheet, and I analyze regression, linear. So I'm doing the same thing again, but this time I do something else. I write down collinearity and Durbin-Watson test. I continue. Do I have something in the save? No need. Do I have any options here? Something interesting? No need. Statistics? Yes. Yeah, go ahead.
No, nothing anymore.
Okay. And then okay. Your results will be same. Everything is coming same. But now, something more is coming here. And this is called R square. Can you see here, R square? Yeah? How much is this? R square. And how much is R square? is 0.191, yeah? Is it this 0.191? Or I can say it's 19.1%, yeah? 19.1%. How many variables we had? Independent variables. Let's count. We have free cash flow 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 independent variables. And what is the value here? 19.1. Basically, it means that all 13 variables together are explaining 19.1% change in your dependent variable. So all the independent variable together combined are explaining 19.1% movement in your dependent variable, which is annualized firm stock return. So 19.1% change we know, let's call it 20%. It means that the 80% change, this model is not able to explain. So this model is only explaining 20% movement or changes in your dependent variable. Rest 80% changes, we are not able to explain. And again, once again, there is no pressure that you should explain 80% or 90%. No. Even if you're able to explain 2%, 3%, 4%, doesn't matter at all. So why are you able to explain less than 100%? Because you might not know some other variables. You know, for example, in this model, did I take something about politics, political situation, law and order? Did I take it? No, they could be the reasons. But what I'm trying to say that the model which have been the variable which theory has told me to pick up in the lit review, they are only explaining 20% change in the dependent variable. The 80% change is somewhere else. Maybe I should have taken some different variables, okay? Or maybe I should have taken the different form of the variables, or maybe my model should have been different. You know, those things I won't explain all of them, but something is missing there. But you are missing something is not a crime, because you didn't take these variables, all the variables which I took, I didn't take them just out of fun. They all came from the literature review. Okay, this is why the literature review is very important, that even if you fail, there is somebody standing at your back to support you. Okay, so this is why if you don't take the lit review and you just take these random variables, then you can be blamed that why did you take these variables in the first place? But now you can say that, hey, even though my R square is 2%, 3%, but these are the variables which I picked up from the well-read literature. So you have somebody to blame, basically. Okay, does make sense? So this is how the basic form of descriptive correlation and regression we do. Next week when we meet, I would recall a little bit of regression again, but then we will move on to the more technically advanced analytical tools. But don't worry, if I give you these two workshops, it doesn't mean that I will not teach you again. As a matter of fact, when you will be at a stage when you do the data analysis now, you want your findings, then I would be having more one-to-one workshops. But the idea is that some general things you should know right now in a step-by-step process, in a slow process, so that it doesn't look like a shock to you. And see, the analysis is so easy. You have 150 rows or you have 15,000 rows. It takes, again, same time, 10 seconds maximum to get the results. That's it. It's so simple. All right. So if you have any questions, you can ask me. Otherwise, thank you very much.